Good morning, everyone. I hope everyone can hear me. Thank you, Patrick, for the introduction. Very quickly, my name is Giancarlo Cutrignelli. As mentioned, I'm marketing manager for AMS. AMS is a silicon vendor headquartered in Austria, and we are specialized in sensors and wireless interfaces. Why am I joining this group of speakers today? Because I would like to propose to you a complementary view of the payment technology. We all give for granted that NFC is working, and the whole ecosystem is focusing on developing the applications, whether on HCE or on secure element, and we tend to forget that there is a hardware technology behind. We give it for granted, and we get used, and we assume that this is working always in all the infrastructures, in all the cases. But if you have experienced NFC in the latest, from the beginning, from the first prototypes of NFC phones, I think we can say that the performance, the experience was not always the best. Sometimes you had to tap in exact position and reverse and wait and dream that a beep will sooner or later come. So AMS has contributed to go beyond this step and to create a disruptive technology. And that's why I'm starting the presentation with this screenshot. Some of you might be old enough to remember this commercial. This was aired at the baseball in US, at the Super Bowl, sorry, in the US in 1984. This was a commercial from Apple. Back then, IBM was dominating the PC world, and Apple, with the Apple Macintosh, wanted to say, now we are disrupting the existing technology. We are proposing to you a new way to experience a personal computer. And I'm using this screenshot because it gives me the keyword, the underlying punchline of this presentation, which is disruption. It was a silent disruption. Maybe you didn't notice, but it's there. If you can pay, next. If you can pay with your watch, just pointing at the terminal in any direction, maybe like this, or like this, is thanks to a technology provided by AMS. We call this technology boosted NFC. It's a new way to make the NFC device interact with the terminal. If you remember the early days, if you open an old Samsung phone, one of the first Galaxy S, you might have noticed a very large antenna in the battery pack. This was very large, and despite this huge size of the antenna, you had to get very, very close to the terminal to make it work. This is not anymore the case. This is a clear comparison of what we were just yesterday, just before the iPhone 6 and the Apple Watch, and where we stand today. And I'm showing this also because if you are hardware manufacturers, but even if you are application or service providers, you need to cope with the new user experience and the new form factor. Creating a payment experience on a watch, on a wearable, is not the same as creating this on a phone. Now look at the comparison. This is pretty simple to understand. You take a contactless card. It's a passive card with a large antenna, and then the performance you could expect across the infrastructure is around 4-6 centimeters. Why 4 to 6? Because the infrastructure is different. If the type of readers around, the size of the antenna, the emitted power of these readers varies a lot. In China, there are even some readers who do not comply to the most basic ISO standards. Okay? Then they don't care, yes. If you look at the old NFC phones, you can hope to have between 2 and 4 centimeters read range. That's the past. What is today? Today you have an iPhone with a much smaller antenna that goes up to 11 centimeters in some infrastructures. And then you have the Apple Watch, which goes up to 8 centimeters. Now, there are a few elements in this slide that, where I would like to draw your attention. First of all, the iPhone is made of metal. The case is a metal. If you know something about RF, you will know that metal is an enemy of RF, especially of NFC. back with the traditional technology, it would be impossible to have a metal case for a watch or for a phone and to have an NFC transaction. With the boosted NFC from AMS, not only a metal case is compatible with NFC, but actually the metal case itself can be used as an antenna. What is the consequence? You boost the performance, but at the same time you can reduce the size. You reduce the footprint, you reduce the cost of producing or embedding NFC. One other thing in this slide is very important. If you can see the difference in antenna size between the iPhone and the Apple Watch. Despite the fact the Apple Watch has a shorter operating distance, the antenna is roughly 3 times as big as in the iPhone. This should hint to a complexity of implementing NFC in small form factors, where a display is packed together with a battery, together with sensors, and together with NFC functionality. It's much, much more challenging to have NFC payment functionality with a positive user experience on a wearable than it is on a phone. What are the keys, the pillars of the boosted NFC technology that we have deployed in the market? Quickly, performance. Usability, how convenient it is to use this technology in different form factors. Power consumption. Sami was mentioning that the Google Glass will last half an hour, and this is definitely inconvenient. Power consumption is an issue if you want to use NFC. You don't want to go in a petrol station and just at the moment you pay with your phone, then you don't have, or your wearable, you don't have enough power to do that. That's time-consuming and embarrassing. Interoperability. As I mentioned, some infrastructure is not even compliant to standards. And then a footprint. I will go through these points very quickly, and I hope I will save some time for your questions. First of all, performance. I mentioned about operating distance, right? In AMS, we are moving from the term operating distance to operating volume. Why? Because as soon as you get a little bit far from the terminal, if it's not 2 centimeters anymore, it becomes 4, 5, 11 centimeters, then you can consider that there is a volume around the terminal where when your phone or your wearable is getting into, can already interact with the terminal and do a transaction. What is the impact of this increased performance? First of all, you don't have to point your device exactly in one position. It's ease of use. It's intuitive. The second point is that fundamentally you can position your reader in different ways. You don't have to create it. You don't have to hand your phone in a special way with the fingertips and try to find the right position. You can also point it. You can point it down. You can point it up, and you can use a wearable. And the other effect is that if you get this boost in performance, you can reduce the antenna size and reduce the footprint. Usability. Now you imagine, you want to pay for transit, you go to the station, you want to pay with your watch. Sami was mentioning, if I have a $1,000 watch, I don't want to scratch it on a gate every single day to pay for that, right? So you want to keep it to a distance. Not only, maybe you want to pay on the other side. So you can pay with the face down if the reader is horizontal, but with boosted NFC, you can also pay on the other side. Because given the volume, given the presence of an operating volume around your wrist, you have all this space available for the payment. And this becomes convenient whether it's a vending machine, whether it's a transit gate, or whether it's a payment, a point-of-sale terminal in a retail store. Okay? Power consumption. Power consumption is an essential, let's say, it could be a killer for a certain technology in a form factor. Maybe a smartwatch would have enough juice to have NFC, maybe 400 milliamps per hour, no? A big battery, but not maybe a smartband. I'm meeting a lot of brands and OEMs which are not trying to develop a futuristic design for their smartwatch. They want to embed in a traditional, classic-looking watch NFC functionality, right? And normally those watches have a small battery. They don't want to become thicker, right? So there is a very small space to put the battery. Now, just a simple calculation. If I took two examples from the web, with a 35 milliamps per hour, so a very tiny battery in a smart band, and then a elegant smartwatch with 160 milliamps per hour, which is a coin cell. It's nothing special, it's a coin cell. Look at the first case. If you implemented NFC as it is today, designed for smartphones, you will get from up to 5 days claimed battery lifetime, you will get down to less than 3 days. If you go to to the second case, from 8 months claimed battery lifetime, you go down to a little bit more than a month, and then you have to physically replace the battery. This is a killer. No one would implement it this way. So we need to find new architectures for NFC which are meeting the expectations of the user, but at the same time also not destroy the expectation from durability lifetime of a certain device. Interoperability, I mentioned about that. So you might not be totally aware, but there is a huge variation of performance out there. If you look at a single region like France or Italy or UK, probably the infrastructure is more homogeneous. But your customers are not only staying in UK, not only in France, they travel. And they use the technology if the technology gives the same response across the globe. If you go across the globe, then you will notice on the same implementation a huge variation. Here in this example, between 4 and 14 centimeters read range across infrastructure. This is a huge difference. It's a huge difference. And many customers I'm meeting actually leave the field trials in the very last stage. When the device is ready, they implement NFC, they try, and they are forced to long fine-tuning to make it work in certain infrastructures. And what I suggest my customers to do is not to do the first experiments in a lab with the single reader, but prepare an interoperability test bench to try already in a very early stage of development the interoperability across the infrastructures. I'm almost done. I would like just to give a word on about footprint. Footprint means the space occupied in a design by a certain technology. Okay? We talked about smaller antennas, and boosted NFC is already giving you the chance to reduce down to 100 square millimeters, so a fingernail, the size of the antenna. And back in times it was 1,000 square millimeters, and that's done. But there is another impact of the different form factors that is related to the fact that NFC, in the way the architecture of NFC, in the way it has been designed until now, had a phone form factor in mind. It was designed for phones. It was not designed for wearables. And in wearables you have different needs. Maybe you have only host card emulation in the case of Android phones, and then you don't need a secure element. You don't have a SIM card slot. You don't have a micro SD slot in a wearable. And this is simplifying enormously the architecture of NFC. If you look at what ABI is predicting, this is pretty new, this just came out in September from ABI research. They're predicting that a growing portion of NFC implementations will not be standalone NFC chips, but they will be integrated. In the same way like Bluetooth or Wi-Fi have been integrated into application controllers. Look at what Qualcomm did, for example, of MediaTek. NFC, with an attach rate next year around 52%, predicted by 52%, with such an attach rate, it makes sense to integrate NFC into the baseband. which means that you will get NFC functionality somehow for free along with the application processor. This is actually, my personal opinion is that those numbers are still very, very shy, very small. I think at the portion will be much higher if the wearable market is going to drive adoption of more advanced solutions. And the second statistic there is very interesting. I would like maybe to ask Jill to give a confirmation of that. Some surveys on the web say that Apple Pay users, if they can choose between the Apple Watch or the iPhone, they prefer to use the Apple Watch for paying, which is maybe something as a retailer you wouldn't know. Yeah, exactly. At least you are not forbidden to use a watch. But this is interesting. If this is confirmed, it means that the wearable on your wrist is a preferred choice of payment. And this, for the whole ecosystem, should be a message. Should think, maybe we should rethink our strategy, and maybe we should develop a strategy dedicated for wearables in terms of user experience, in terms of usability, in terms of infrastructure. And then I would just like to conclude with some, let me say, recommendations or conclusions from our side. As technology providers, we invite the ecosystem to think in a new way. NFC is still full of disruptive technologies from service perspective, architecture perspective, but also hardware perspective. Our suggestions for the future is integrate. If you are a hardware developer, integrate NFC. Request, ask, expect that NFC becomes a default feature of a certain platform. Choose upgradable and flexible solutions. NFC in the way it's conceived today is is compliant to standards. Every protocol, every connection has been standardized to create portability of the solutions. But on the other hand, you want to make sure that a device is able to be upgraded on the field with new applications and with new capabilities. Look for power-efficient architectures. Don't think about the user interface only. Think about how your services are affecting the user experience in terms of durability of the battery of the wearable. Test and validate across infrastructures. Do not accept a rough functionality with a single reader. Try across the different infrastructures. You will find surprises there. And last, do not forget that performance always translates in user experience. Thank you very much.